Hi, my name is Stephen Laney, and this is my end of the term project for CIT 220. We have been given the task of going through a couple different topics that we've been learning here at the end of the class and showing examples in our game, in our code of these different topics. And so I'm going to go through them, starting with the first one, which is static and non-static variables. So with static, non-static variables, the difference between the two, so the non-static variables, those are created first within a specific instance. And so anytime that you leave this instance and you want to call this variable, you're going to have to create a new object. And so it's only stored in memory whenever it's being used, and it's recreated and put into memory whenever you have a new object created for it. And so they're very specific to an object. Whereas a static variable, they're called the one time into the program. Their memory is allocated in the one time for the program, and they are loaded with the class. And so the syntax, you'll have the class name dot variable name, and that's how you'll call it. So it's a lot more simple to work with. I have a couple examples. This first one's a non-static variable, and you can see that tank volume, it's not static. It doesn't have the static syntax here, and it's created here within this code. And then here, where I'm going to be printing out a line referencing to tank volume, I had to create, because it's non-static, I had to create a new object here of tank volume, and so this is actually being created twice, once with this object, once with this one. Whereas here we have a static variable, and this static variable is being it's created here with this static here in the beginning, and so when I return it, here we can see in this taught Coral View class, I had imported the Play Puzzle class, or Play Puzzle Control class, and I'm actually calling it with the class name here and the variable name here. Because it's static, it comes with the class, and so it's a lot easier to work with. The next topic that we have is talk about an array list, and enum. The difference between them also, an array, it's fixed when you create it, but you can add and subtract from it. You can change the value when the actual code's in execution, but it only has the same value type once it's been created, where an array list, pretty much the same thing, except for it can be made with many different array types, or many different types of objects, and so it makes it a little bit more versatile to work with. Whereas an enum is fixed on all bases. You create it, you add all your different list items in the enum, and then you don't make any changes to it. You call it, you reference it, but it's very fixed after you create it. And so an enum's more like a menu item, or if you have a list of characters that aren't going to be going anywhere, you'll create an enum for them, where an array is going to be a list of objects you might be adding and subtracting to that are all of one type. Or an array list might be an array of items that has different quantity associated with them, so you have a different couple different types with them. Right here is an example of an enum that we have. The enum is specified with this enum syntax up here at the top, all separated with commas. The right here is an array. The array is created with these square brackets, and then you have all the same type. This is all just a bunch of strings, and this right here is an array list, whereas you can see there are different objects within this array list, and this is created with the greater than and less than sign. If you want to access an array and the different elements stored within an array, I have an example here. So this right here is an array. This right here is calling to an array. The array being right here in our game control. You can see that I have the array here. It's got the different all the different items in it and everything, all the everything that goes here in the array. And what we're doing is we're calling to items, and we are inserting here in a table that executes out in the code. This description, quantity in stock, set required amount. It calls all these and it kicks them out here within the game menu view, accessing all the elements stored here within the array. The next topic is talking about throwing, the try catch. The whole purpose for the for throwing and for the try catch is to allow your code to execute more smoothly whenever there are errors. If there's an error, typically your code crashes if there's a runtime error. And so you want to make sure that that doesn't happen if it's an error that the user performed entering in something that they shouldn't have. And so so here we have a throw statement that has been placed here in this if-then statement to be able to catch an error. If there's an error, it's going to kick out this response. It also makes finding the error a lot more efficient instead of going through each instance in which this variable is called. This throw is going to throw it right up to the beginning, so that way the location of the error is found much more promptly. With a try catch, the try is going to be searching for an error within its parameters, and so it's little brackets that you have here. It's going to be searching for an error within it. For this specific instance, we have the try catch right here for the location visited count. So we have here within here, it's calling this code. So if there's an error associated with these parameters, it will catch it here within this catch statement. The try will find it, it'll send it to the catch, and the catch will display this message that we have inserted here, letting the user know that they've done something wrong and that they need to perform differently within the code. And this all happens without the program crashing, which makes it a lot easier to use the program when you're actually using it. You don't have to crash the program, find out what you did wrong, and then go back through the entire thing. You can correct yourself on the go. So the next item of business is character streams versus byte streams. So the difference between a character stream and a byte stream. So originally Java, it only had support for byte file streams, and these are streams that read and write data that's uh, binary. And so there's not a lot of support for other languages due to the restrictions that byte streams have. They're they're most normally used for pretty much that, writing, reading binary data files to other processes elsewhere. And so, if that's what you want to do, a byte stream is fine. But with character file streams, they were added because the default storing character in Java is Unicode. Unicode, it's a lot more broad. It envelops a lot more more characters, but it can't be read or written by a byte file stream, and so that's where it kind of gets its name, or that's where it gets brought in, the character file stream. And so the difference, you usually see them here in the code. This up here, we brought it in the beginning when we were first coding. This system.out.println, whenever you see this is a byte file stream, and any of these this.console.printlines, this is a character file stream. And so the next order of business is one of the individual assignments I did, and how it has to do with writing character data to an external file. So this one right down right here, I decided to go with the print writer style or type whenever you're writing to an external file. It worked very smoothly for what I had in mind with our code. What I want to do is print an inventory report, and so you create it here. You call your different classes, make sure that they're present, and you signify where and what you want it to be called, where it's going to be created, this external file. It was just going to be a text file, and it creates kind of the formatting right here, and the different descriptions and everything that's going to be in there, and then it actually calls the different information that I want to be in the report. And so here with the out.println, this is just the header that's going to be up on the top, and the out.printf. These are the lines that go underneath. And so this being the formatting, this is going to be a new line. After each formatting command, you have the percentage sign. And so this dash right here is going to be formatting it to the left, 25 characters string, 10 characters string. And so that's all going to be applying to this text. 25 character spacing, it's going to be a string. When you get down here to the actual data, that's when you have the integers. This D for the data integer, that's going to be used right there. And so it pulls it out and terminates the function, and everything gets printed to that external file. So that's kind of how that works. So very quick demonstration, so I don't go too over on time, of our actual code working, our game working. We're going to go ahead and run it real quick, and I'll walk you through it and what we have. So when you tell it to play, you have to enter a name. If not, it's going to give you an error. So go ahead and enter your name. It's going to welcome you. If you go into start a new game, it'll bring you to a game menu. In the game menu, we have this map. Here's the very first thing that you can look at. It brings us with, presents us with a two-dimensional array of locations. All these different locations you can go to whichever way that you want. You do that by going to this go to new location. When you go to that, it's going to ask you for a desired location. When you type one in, like this first one, DI, which is Dijon, it's going to bring forth the scene that's within that location, and it's going to present you with a challenge. This challenge is completed by giving the correct answer. If you give the wrong answer, it's going to ask you to try again. So give the right answer, it's going to give you some some further context pertaining to the story. So each time we go to a different location, it's going to keep track of both where we are and where we've been, and then it's going to give you some data down here pertaining to both where you've been and how much of all the locations you've been to. And so if we go to another location, LY, again, it's going to present us with the challenge. We complete it. We go to another one. Let's skip a location, give us another challenge. And I believe it's one. Yes. So now whenever we look at the map, we're going to see all these different locations that we visited and where we're currently at. So if I wanted to go back to the main menu, I can save the game. I just have to tell it where I want to save it to. Desktop, typo right there. But now if I start a new game, if I look at the map, it is a new game. Everything has been erased. If I want to restart previous game, a previous game, I'll go to R. I'll type in what I typed in before, which was desktop. Okay, and so now when I look at the map, I'm going to have what I had previously, so it had been saved. You go through all the locations, it'll give you clues and further information as to what's going on with the story, and in the end, everything pieces together and makes sense. And so that there is our game, and we had a lot of fun making it here in this class. Very informative class. And that is my final presentation. Thank you.